Dear students, I hope you all are well and enjoying your online classes. Today we'll start the new chapter Analytical Chemistry. Analytical chemistry. First, you have to know about what is the means analytical. So, analytical means to analyze something, okay, or to go in depth about something, whatever it was in play in field of chemistry, or you can go in depth for a person. But in case of chemistry, when this chemistry terms comes, analytical chemistry, you go in depth or analyze the chemical substances. So what you have to discover or cover in this syllabus: action of ammonium hydroxide and sodium hydroxide on solution of salts, color of salt and its solution, formation and color of hydroxide precipitated for solutions of salt of calcium, iron, copper, zinc, and lead. Special action of ammonium hydroxide or solution of copper salt and sodium hydroxide on ammonium salts. So you can see, if in previous chapters you already read about the salts, how they prepare, and what their chemical and physical properties. So as you move on next to next chapters, you always find a new things about any compound you read. Okay, on solution of salts, color of salt and its solution, action on addition of sodium hydroxide to solution of calcium, iron, copper, zinc, and lead. These things you have to read in this chapter, and action of alkalis also. Okay, like sodium hydroxide and potassium hydroxide on certain metals, their oxides and hydroxides. So we start the chapter, the branch of chemistry which deals with the analysis of a chemical substance or its solution to explore its nature, composition, and constitution, is called analytical chemistry. So in this analytical chemistry, you just analysis a chemical substance or a solution, and what you explore or find its nature and its composition, and what components are found within it. It means its constitution is called analytical chemistry. So analytical chemistry is a type of experimental chemistry and deals with the following two types of analysis. First is qualitative, second is quantitative. In qualitative analysis, the nature and quality of the substance under examination are determined, and in quantitative, it deals with the determination of constituents of a chemical substances in a mixture. Okay, of a mixture, you can say. It means, as name suggests, qualitative, you can check the quality of any substance. Okay, and in this quantitative, you can determine the number or quantity wise, or which number of constituents found in that chemical substance or mixture. So in this chapter, we mainly discussed about the important aspects of qualitative analysis, in which identification of unknown substances and its constituents is done by chemical test involving various reagents. The term reagents comes here. It means a reagent is the substance which reacts with some other substance and is used to carry out a chemical reaction or chemical test, useful in identification of the given unknown substances, as ammonium hydroxide and sodium hydroxide are very important reagents and are frequently used in quantitative or qualitative analysis. Now we read about the color of salts and their solutions. As you already know, in chapter chemical bonding, you have read about the electrovalent compounds, which consist of positive and negative charges and linked together through electrostatic force of attraction. The positively charged ion is called anion and cation, and it contains a basic radical. Okay, because it comes from the base during neutralization process, whereas a negative ion is called anion or acidic radical because it comes from the acid. Okay, during neutralization process, ions may be colorless as well as colored. The color of a salt is due to the presence of colored ion in it. Okay, and for example, copper sulfate is a blue colored salt and forms a blue solution when dissolved in water. It consists of cupric and sulfate ions. Okay, you can see that copper sulfate, cupric and sulfate ions it carries, and cupric ions are blue colored while sulfate ions are colorless. Due to the presence of blue colored cupric ions, whenever two valency is there, it means cupric, and plus 3 means cuprous. So cupric ions, the aqueous solution of copper sulfate is blue. So you can see CuSO4, when they dissolve in water, it get converted into its ions, cupric ion and sulfate ions. Because it is sulfate ion is colorless, so the solution is blue in color. Regarding the color of ions, following generalization can be made. So what you can made, the ions of normal elements, that is the elements of group first A to 7th A, are colorless. This is why the salts of almost all the normal elements are usually colorless. And second, the ions of transitional elements, okay, d block elements mainly, the elements of group 1b, 2nd b and 8th group, lanthanides and actinides, are generally colored. This is why the salts of transitional elements, lanthanides and actinides, are usually colored. The color of a salt helps in its identification in qualitative analysis. The colors of some important cations are given in table 4.1. You can see here colors of some colored cations and anions. You can read them and try to understand and learn. Cupric ion, blue in color. Ferrous ion is light color. Ferric ion is pale yellow color. Chromate ion, yellow color. Dichromate is in orange color. And last, permanganate ion is pink color. Some important colorless cations and anions listed in table 4.2. These are all these all are colorless. Ammonium ion, sodium ion, potassium ion, magnesium ion, calcium ion, aluminium ion, lead ion, zinc ion, and by seeing this you can also learn their valency. Chloride ion, bromide ion, carbonate ion, bicarbonate ion, sulfate ion, hydrogen sulfate ion or bisulfate ion, bisulfate ion, oxide ion, sulfide ion or phosphate ion. So these are the symbol of them. Now if we talk about use of ammonium hydroxide in analytical chemistry, it is an important reagent and finds a variety of applications in qualitative analysis. It is mainly used for following purposes in qualitative analysis. Okay, first is for precipitation of metal cations. And what is the precipitation? It is the process which involves the formation of an insoluble substance on mixing two or more solutions together. Okay, formation of insoluble substances by mixing of two or more solutions together. The insoluble substance thus formed is called a precipitate. Okay, ammonium hydroxide precipitates several metal cations from their salt solution. Okay, these precipitates have different colors and are very helpful in the detection of cations. So by forming precipitates of metal ions with the help of ammonium hydroxide, we can actually detect the cations. And second use of ammonium hydroxide is formation of complex salts. Ammonium hydroxide forms complex salts with certain metal cations. These salts have distinct colors and help in detection of metal cations. Okay, so all these processes, whatever we take, we identify or detect the metal cations. Next is for making medium weakly base. Okay, ammonium hydroxide is a weak base. Its presence in a solution makes the medium weakly basic, which is helpful in the detection of certain radicals. Next is for providing ammonia. Whenever ammonia is required for a particular test, ammonium hydroxide is generally used for the purpose because it is an aqueous solution of ammonia. Okay, whenever we need ammonia from ammonium hydroxide, we get it because it's already a aqueous solution of ammonia, or you can say aqueous solution of ammonia is ammonium hydroxide because hydroxide means water in that. Okay, so these are some uses of ammonium hydroxide. Now you have to read from your home action of ammonium hydroxide on certain salt solution and try to understand them. Okay, we can discuss in the next class all in details. If possible, I also try to make this video on an animation basis which you can understand more in detail. Thank you.